Hello, everyone. Welcome to the next installment of the FRC workshop series here in Australia. Tonight we have Magic Smoke, How to Keep It In. I've heard that people are enjoying the titles, so I know that we're going to learn a lot about how to keep smoke inside of our robot, because that's a super important thing to do. Tonight we have a couple of mentors coming to you from Project Bucephalus, that's FRC team 5985. We have Simon, you want to give us a wave? And Graham? And they're going to talk to us all about sensors and electronics. And I know that we're all really looking forward to learning more about those. So I'll turn the show over to the two of you.
Great, thanks, Lauren. So tonight we'd like to talk about three main areas. We'd like to talk about a little bit about electrical safety. So when we're working on the robot, how to maintain safety and how to protect our robots as well. We want to look at understanding and using the various electronic components that make up an FRC control system. And we'd also like to talk a little bit about sensors and how you can use those for different applications on your robot.
All right, next slide, please. So, one more slide, please. What is the most dangerous part of your robot? As far as I'm concerned, the most dangerous part is this. If we can get a camera up, please. Basically, it's the battery. So battery has, apart from a small amount of energy that you can have in your pneumatic system, is responsible for storing pretty much all the energy that your robot gets to use. One of the issues with that, it's known as a sealed lead acid battery. The acid being the important part there, it is full of acid, which has a bit of a safety implication. If you short circuit one of these batteries, well, firstly, you've got your electrical connections that normally connect to your robot. It'll draw what power it needs. If you short circuit it, you can get 1,000, 2,000 amps flowing. And that causes the power not to dissipate by moving a robot, but actually into the acid in the battery. Heating up the acid, they can vent, they have safety devices built in, and in rare instances, they can explode. So treat this battery carefully. Don't use a damaged battery. I will share one issue we had with our battery. We had a battery enclosure that had a bit of angle like this on the front of the battery with the battery sitting down in there. That worked well, it contained the battery, except for one match when the battery was installed upside down. And I'm not going to push it down there, but basically these two well-taped up terminals were hitting against the edge of the aluminium. And as the robot rocked during the match, it went bang, 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 and actually broke its way through the insulation. And we had some quite spectacular sparks shooting out the bottom of our robot in the middle of the match. The refs didn't actually notice that and let the robot keep going, but it's quite clear on the video. We will actually show a photo of that later. But that's just learning from our mistakes lesson. So yeah, don't design your battery mounts so that you can actually hit on your insulated terminals.
So, just talking a little bit more about electrical safety on the robot. So we can just move on one more. The first thing that we'd like to talk about is always make sure that the breaker is turned off before you touch anything on the robot. Not only is that safety because you've got motors and chains and things like that can remove fingers and hair and things like that, but also because it's much more likely that you might short something and create the kind of incident that Graham's talking about if the breaker's turned on. If you're doing any serious mechanical work on the robot, you should actually be removing the battery from, if you're drilling into your robot, cutting anything, the battery needs to be removed completely from the robot. And as Graham said, the last thing there is learn from the mistakes that we've made. There's things that you do and don't want to do with batteries.
So the battery, which we've talked about, is a very, very specific type of battery. There's a list in the game manual. It's of approved types, but it's a 12 volt, 18 amp hour sealed lead acid battery. And the approved types are, despite the fact that I talked about explosions, they are generally very safe. So keep to that list.
Yep. So we move on then to starting to look at the actual components that make up the electrical systems within the robot. So the first thing we want to talk about is the main breaker. So it's a part that's required under the rules. It's specified in the manual. You have to use the breaker that's supplied, so there's no choice about that. It needs to be easily accessible from outside the robot. It's a safety device, which one of its primary functions is to allow the power to be quickly shut off from a robot in the event that something goes wrong. So it needs to be easily accessible. It can't be buried underneath the robot, tucked away inside the mechanism somewhere. It has to be easily accessible. You may want to consider actually highlighting or drawing attention to where that breaker is located on your robot with some kind of sticker, not on the pneumatics, that's another thing to learn from, but a sticker somewhere on your robot which actually identifies where the main breaker actually is. The other thing is, make sure it is protected, even though it needs to be easily accessible. Make sure it's protected from being hit, for example, by a power cell, because the last thing you want to happen in the game is for someone to accidentally bump into your breaker or shoot it with a power cell and turn your robot off in the middle of the game. So it needs to be easily accessible, but somewhat protected.
The next critical part of your power supply for a robot is your power compulsory, as far as you must use a PDP, you must use one PDP, and you must use this particular PDP. So the PDP, it takes the power from the battery after it's gone through the breaker, and it will supply each of your individual sub-circuits. This is the PDP from our 2020 robot. As you can see, there are 16 sub-circuits. That is actually limiting how many motors you can have on your robot. So we have terminals here come from the battery. These things here are individual circuit breakers. They are self-resetting circuit breakers that will trip if you exceed the rated current, which is written on the top. And these are some of the smaller circuits down here. And then we've got all the connectors down the side that connect out to each individual motor controller. And you'll notice the wires on those are quite fat. Then Simon, if you move it down to the end a bit, these connectors here, they connect out to your pneumatics control module and your voltage regulator module so that you can power your Robo-Rio, your radio, and your pneumatics. The other thing that's on this is your CAN bus connection. So even if you're not using CAN bus for anything else, you must connect the CAN bus to your PDP. It is part of the inbuilt safety functionality of the FRC robot parts that must be connected.
So the next part of the robot control systems or electronic systems that we need to look at is the VRM or voltage regulator module. So its most important function the VRM performs is to supply power for your radio field. So it's a very important function that the VRM provides. It can provide power for other devices as well, but generally most people would recommend that the VRM which is supplying power to your radio is only used to supply power to your radio. If you need a VRM for other circuits, consider other ways that you might supply that power. You don't want to have something go wrong and trip the power to your VRM and take your radio out mid-competition.
Right, next critical part of the robot is the RSL, the robot service light. If you've ever seen an FRC competition, they're very, very visible. They're the orange flashy things that every robot must have. They're very, very simple to wire up. They just connect directly to your Robo-Rio, as you can see in the photo on the screen there. And you must have one per robot. You can have two, and they need to be clearly visible.
So the actual radio itself that we talked about briefly. So again, this is a specified component. You have to use the radio as is specified and supplied in your kit of parts. Radio has different kinds of power connectors on it. One being the traditional, I imagine, but It's just one of those little black barrel type plugs that you're all very familiar with.
That one there.
That one there. The other one is the orange cable that Graham's thumb is pointing at, which is the PoE injector cable. So PoE stands for Power over Ethernet. Really important thing to pay attention to is it's not real power over Ethernet. It's what we call passive power over Ethernet. So it's not true power over Ethernet. The radio has 2 Ethernet ports which can be used. One of them is used for the connection between the radio and the Rio, which is there somewhere. It's the red wire. It's there. The other one can be used either for tethering your robot if you're doing tethered practice runs back to your driver station, or it can be used for connecting to other network devices such as cameras and things like that on your robot. It does need firmware to be updated at the beginning of every season generally and at competition, but that's something that you can find details for in some of the links later. Just a few minor points on the radio. It's not really designed for a robot or an industrial application. It's a domestic consumer product. So it doesn't like large amounts of vibration. It doesn't like large amounts of shock. There's actually an inbuilt plate in the bottom of the robot which can short the power supply. Sorry, in the bottom of the radio, which can short the power supply. And that can actually cause your radio to reboot and will leave you dead for about 60 seconds in the match. So you don't want to, when you mount your radio, it needs to be reasonably solidly mounted, but don't put too much pressure on the top or bottom of the radio, or you can induce that closeness of that plate and cause it to cause that short and the fault to occur during the match.
I believe there was actually a rule saying that you could modify the radio by putting a bit of tape inside it.
It is quite a complicated procedure to pull the radio apart to do it, but you can do it. If you want to take that completely out of the game, you can actually pull the radio apart, tape over that plate and prevent that from happening.
So the next part of the robot is a Robo-Rio. This is the brain of the robot and is where your software will go. So on a Robo-Rio, you have a CAN bus connector at the top left there that will connect to all of the, will connect to the PDP, Pneumatics module and any other CAN bus devices you have. We've got an Ethernet port for the radio. There are USB ports. So the type B USB port is for the tethering to the robot itself. So there's your type B one for tethering. These 2 type A USB ports, they are for plugging in devices such as web cameras. If we have a look around there, you've got an I2C, which is for communication with various sensors. For example, the 2020 kit of parts had a color sensor that's I2C. RS232 for other serial communications. Digital input outputs, so you can have sensors there, they can process encoders and various other things. There is your robot service light connector. You can drive relays and you can have analog inputs. And then on here, we can have pulse width modulation. That's what PWM stands for. That will allow you to drive some of the more simple motor controllers, just to give them a reference if you don't want any of the fancy stuff. And up here is the SPI, and that will allow you to connect to a variety of different things using a serial interface as well. The other thing here is the large, I think it's an MXP port. That's an expansion port, and we actually on some of our robots have cards that plug into there to give extra functionality such as gyroscopes and accelerometers. As you can see on this one, we have actually damaged our USB port, so tried not to do what we've done. We have also at times tried to, this thing here is a cover that we've made to cover the holes. Other times we've just put tape over the things to stop dirt and aluminium shavings and all sorts of stuff getting in there, because that's not that great for the electronics board. All right.
Okay, so we can move on to one more if we can. So there's 2 kinds of motors which you'll find on FRC robots nowadays. Traditionally, robots have used what's called a brushed motor, which effectively is a motor with an electromagnet that spins inside a set of permanent magnets, which is how the rotation is generated in the motor. The other kind of motor, which is becoming a lot more common now, a lot more popular, it's what's called a brushless motor. And a brushless motor, as you can see from the diagram that hopefully you're seeing, has the electromagnets fixed around the outside of the motor and the spinning armature in the middle, is where the permanent magnets are. So why the hype about brushless motors? Most people tend to believe that they're more powerful, especially more powerful for their weight. So I guess the power to weight ratio, if you want to use that term, on a brushless motor is greater. So they're lighter. They're inherently more reliable. They have this in them. So when the brush held against a spinning metal commutator, they eventually wear down. And once they wear down too much, you get poorer connections and eventually your motor fails. So brushless motors don't have that problem. They are more expensive, and so are the motor controllers. So it is something to bear in mind if you're thinking about which way you want to go, brushed or brushless. They're more expensive. And the really, really important thing, you must use a specially designed brushless motor controller if you're going to use a brushless motor. If you hook a brushless motor up to a brushed motor controller, you will let out the magic smoke.
Now, for the most common brushed motors in FRC, and most teams will probably have quite a few of all of these as they're often in the kit of parts. The SIM and mini SIM, which is quite a large, substantial, heavy motor. 775 Pro, a red line motor, and a bag motor, which looks in that photo about the same as the SIM, but it's actually quite a lot smaller in practice. They're standard brushed motors that can be run by a standard brushed motor controller.
So there's I believe three brushless motors currently that can be used on FRC robots. There's the Rev Robotics Neo, which has been around for a few years now. And that's the one that we actually use on our robot at the moment. We use some Neos on the drivetrain and also some of the other motor components of the robot. There's a new motor which became available at the beginning of this season. It was this season, wasn't it? I'm confused about this year. Which is also by Rev Robotics, and it's a Neo 550. And it's a smaller, more compact, but less powerful brushless motor. The other one, which was a new one, which came on the scene this year and has been very popular, is the CTRE Falcon 500. So it's a more powerful motor than the Neo. One of the other big distinctions between it is, when I said before that you must use a brushless motor controller with a brushless motor, the Falcon 500 actually combines the motor controller and the motor into a single unit. So instead of having to have a separate motor controller and a separate motor, the Falcon 500 combines the two into a single unit.
So one of the ways of running a motor controller from the Robo Rio is via the PWM, the pulse width modulated signals. These are a very, very basic signal that gives pulses, and the speed is determined by the timing of the pulses. And that's all it can communicate is speed from the Robo Rio to the motor. And it plugs into the PWM ports that we pointed out and goes into the motor controller, which just acts as a high current driver for the motor. So the examples of those, the Victor 888, the Talon SR, and the Spark motor controller are all standard, simple PWM motor controllers that will just control the speed to whatever you give them the signal for.
So then we talk about smart motor controllers. We use the term smart because the motor controller receives a command from your Rio to do something like spin at this speed, something like that, run at this power, whatever the setting might be, and the motor controller actually does the work. So that's a difference between the ones I call dumb. Dumb isn't a very good word for them, but I couldn't think of a better word than dumb at the time. So I had dumb and smart. So the smart motor controllers are given instructions by the Rio in your robot to tell them what to do. They often support some clever things. One of them is called motion profiling, which allows you to change the way the motor behaves depending, for example, if you're extending an arm, you can have it slow the arm down as it gets closer to the end of its travel so it doesn't go thump into the travel and things like that. So the smart motor controllers have some really nice, clever stuff that you can play with. Most of them connect via the CAN bus that Graham pointed out on the Rio before. So that's a signalling bus that allows the Rio to send instructions to other components on the robot. Examples of the smart motor controllers are things like the Victor SPX, the Talon SRX, and the Spark Max. So there's a Spark, which is not a smart motor controller, and there's a Spark Max, which is the brushless motor controller for the Neo. So just be careful about those two.
Okay, so the next thing to talk about is the pneumatic control module. So this is an optional part of your robot. You do not need to have pneumatics. You can run a perfectly serviceable FRC robot with no pneumatics at all. But if you do use pneumatics, then you will need a PCM, a pneumatic control module. So there's our one on our robot. So it sits there on the CAN bus. You can see the yellow and green wires at the top left there. Down the bottom left is one is the connection to the pressure sensor, and the other one is the connection to the compressor. So it will control the compressor and it will turn it on and off when things need to pressurize. The left-hand part is where the power comes into it. Comes in there. Terrible shot. And then the other wires, the wires here, they go to the actual valves themselves. So you can write code in your Robo Rio that can open and close valves, and we will wire those up to our valve manifold, which is up there. And that is basically how you the electrical side of a pneumatic system on a robot.
Okay. Just switch back. So the final part, or the final component of the electrical system that we just want to talk about, is a camera. So most robots will have a camera on them, which is used by your drive team to actually be able to see what the robot is doing out on the field. So because the robot might be quite a long way away from them, facing in different directions, you generally have a USB camera, and we can stream that video feed back to your driver station. So you can have more than one camera on your robot. So you can have front and rear cameras. You can have a camera mounted down low looking in an intake or something like that. But be aware of the amount of bandwidth, the amount of network capacity that all these streaming video feeds are requiring. The FRC field management system restricts the amount of bandwidth that each robot can have during competition. So be aware that something which works beautifully in your workshop, as far as streaming video to your robot goes, may cause you problems at comp because of the restricted bandwidth. So just be aware that if you really need to stream a lot of video, you might need to either choose which cameras you're going to use or change the resolution of the camera that you want to use so that you actually reduce that amount of network bandwidth that you're consuming.
So, connecting it all up. Is this where we do a review of?
We can do it, yeah, might as well.
So,
yeah, we'll have the camera.
Right.
Look at this one first.
Yeah, sure. So, connecting a robot up, you start with battery, as we mentioned previously, and then you wait for Lyndall to get your camera working.
We'll just smile. And now a word from our sponsors.
All right, so we have a battery. That will plug via an Anderson plug, a big, nice, chunky one, into the robot. Now, the first thing that you'll have on the robot is a circuit breaker.
So I'm going to start laughing in a minute.
There. And then you follow the wires from the circuit breaker to the PDP. And the PDP then distributes everything out. So each one of these wires out of the PDP will then go into a motor controller. And then the motor controllers then go off to the actual motors. And here we have a couple of Neos that are run from the Spark Max. Then, out of the end of the PDP, we have our connection to the PCM and to the VRM and to the Robo Rio. not necessarily in that order. Look at the documentation we give you links for later as to exactly how that works. So that will then go all the way over to your power connector on your RoboRio.
So just a little tiny note to interrupt. In this year's robot, we actually split our electronics board into two parts, one on the base of the robot, one on the top. You don't have to do that. They may all be in the one place.
Yes, so there's the base of the robot, and we've got a whole lot of connectors there, and this is the top part which we've taken off just so that we can show you what's on there. But yeah, you've got your into the RoboRio, you've got into your PCM, just there, and then into your VRM. And then out of your VRM, it comes out of there, and we've got two connections into our VRM. I don't know if you can see that very well. There's 4 wires there. One of them goes to the radio to the barrel connector, and the other one goes to the power over Ethernet injector module here, so that we've got both ways of supplying power to the radio.
All right, so we saw lots of connections there, lots of cables being plugged into things. So there's a few things that you need to look at when you are actually doing that wiring up. One of them being what size wire you use for what function. As Graham pointed out earlier, you'll notice that some of the wires on the robot were thicker than others because they're designed to carry more current. And the rule book for each season will have a section in it that tells you if a cable is supplying a load of 10 amps or 20 amps or whatever, then it must be a minimum wire gauge. So you need to make sure that you do that right and use the correct wire gauge. And you also may need to be able to prove at inspection that you've used the right wire gauge. So if your wire is not marked, you may need to bring along some kind of evidence to show that the wire gauge is correct. The length of wires is important. So the longer, and this is one I wasn't particularly happy about. I might show you, no, I'm not showing you. The length of the wire, you want to run power cables especially as short as possible, because over the length of that wire, you have what we call a voltage drop. And when we're talking about a system which is powered by a 12-volt battery, voltage drop becomes quite important. So wherever possible, use short wires. There's a few different kinds of connectors that we've pictured there that you can use. There's the bootlace ferrules, I guess, or ferrules, or whatever you say that word, which are really good for plugging into things like the end of the PDP for the VRM, for the PCM, those sorts of things. They make really good. They're a crimp connector. They go on well, and they provide a really solid, reliable connection into some of those components. The bigger power connectors that you saw on our motor controllers were either the what we call Anderson power poles, which are the small ones that we've shown second on there. And then we have the really big Anderson connector, which is designed for connecting high loads like the robot, the battery. Did you want to put that in? No? Okay.
So the other thing we have on the robot that you will see in various things that you have got with your kit of parts are the star-type washers. They come with your circuit breaker nuts. Battery kits we've bought have had these star washers, and they have a very particular function. And they actually, the star gives you 3 particular benefits. Firstly, the angle on the star gives you a very, very tight springy, a very, very slight springiness to stop the nut from coming undone. Secondly, the angle of the things on the star, if you actually have a look at which way they're always angled to bite in if the nut is undoing. So again, it helps to keep the nut done up. The third thing with them is particularly for electrical connections. When you have a metal surface exposed to air, it will develop a little bit of an oxide layer, an oxide coating, which is an insulator, and that will affect your connections. The serrated edges of the star-type washers will dig in just past that oxide surface into the bare metal underneath, the raw metal, and they will give you a good electrical connection if you do them up tightly. So that is why you will see the serrated star-type washers with your circuit breaker and battery kits. That's there for a reason. So Ethernet. Ethernet is used to connect the robot's radio to the RoboRio. It's also used for tethered operation, so you can unplug the Rio and plug your laptop directly into the RoboRio without using a radio. It can be used to interface to other devices such as cameras. If you're watching carefully when I was panning the camera around the robot, you will notice that our robot actually has an Ethernet switch in it. We have a vision system which does plug into that, and we also use it for tethering. With Ethernet, it is a low voltage signal. It's a low voltage signal wire, so keep it away from power. You don't want to have it near the output of a motor controller. You can get a bit of electrical noise which can interfere. And we use hot melt glue under the tab to prevent accidental removal. So I should note that we don't drown the thing in glue. We're very, very careful and particular about putting the glue in. We don't want to fill it up. But if you are judicious with your use of glue, you can improve your reliability quite a bit by making sure that stays in there.
So the CAN bus, which Graham pointed out to you before, which generally are the green and yellow wires on your robot, it's the main way that the Rio and the other components on your robot communicate with each other. The CAN bus has, I guess, one particular weakness, and that is that it must remain connected at all points. If you get a break in your CAN bus, you will generally find that your CAN bus will stop working, and everything on your robot will also stop working, which is not good. There's also a thing called a terminating resistor at each end of the bus. So the very end of each length of the wire, if you imagine your CAN bus is a continuous wire which is snaking around through all your different motor controllers, through your pneumatics control module, through your PDP, all those sorts of things, at each end of that piece of wire, you need a terminating resistor. And it's important, if that's missing, you will often find that your bus will be unreliable or won't work at all. There are other cables that you'll come across on the robot. Graham talked earlier about PWM, or pulse width modulation, for driving motors. So there's PWM type cables, which are a fairly standard, simple direct connection cable. We have sensor cables. So some cables might be a limit switch, a switch which is activated when something happens. Others might be things like, we'll talk about a bit more later, about encoders. Encoders are particularly, or the cables are, again, particularly sensitive to electrical noise. So we'll talk a little bit later about things that you can do to try and avoid problems with those cables as well.
All right. Next, we're going to talk a bit about inspection. So for those who have never actually been to a tournament, as soon as you get there, you want to get your robot past inspection as soon as possible. That will allow you to get out on the field and do some practice matches. Inspection is basically for safety reasons. So first thing I would suggest every team does right near the beginning of the season is download and have a look at the inspection checklist. They are available online, and they will tell you exactly what the robot inspectors are looking for. The robot inspectors will call you over, or you'll have to go over to them. They will go through the checklist. They'll point out sharp edges and things like that, and maybe give you a list of things you've got to fix.
So there'll be things that they will look for specifically. So expect the inspector to take out a multimeter and measure to make sure there's no connection between either the positive or negative side of your electrical system to the metal chassis of your robot. They will look to make sure that there is clear and easy access to the main breaker. They will look to make sure that the PDP, which Graham pointed out to you earlier, and its breakers are easily visible as well. If you're running pneumatics on your robot, they will test the pressure control on your robot. They will make sure that your robot cannot exceed the specified pressure under the rules. They will look for correct wire sizes and types, and even colours of wires. If you look in your game manual, you will see it will tell you that a power cable can be certain sizes and certain colours. They will check those sorts of things. Oh, sorry, that's right. Sorry, I know that's sorry, forgive me. They will actually check to make sure, one of the rules specifically says that the radio must be powered from the VRM, not directly from the PDP or any other control module. Anyway, it needs to be powered directly from the PDP. Okay, sorry,
Yeah.
forgive me, I'm confused.
Yes.
It needs to be powered directly from the PDP, and they will actually check for that in inspection.
All right, this is the photo that I mentioned earlier. Sorry, that's our robot at the I think it was the South Pacific Regional, with sparks shooting out the bottom of it. That was when we had our battery shorted out, and as you can see, it's at a bit of an angle because it was being jolted back and forwards a bit. Luckily, it didn't get any worse than that, but you could see a few scorch marks on the robot after that match.
So some of the things that we like to do, having learnt from experience, when we're checking our robot before we put it on the field, we like to do the tug test. We actually like to take our crimped connections and give them a good solid tug to make sure they don't fail. We also check the bootlace connectors in the same way, give them a decent tug, not ridiculous, but a decent tug to make sure they don't come out easily. Neatness is something that we found is really important in electronics. When you're in a queue to get on the field for your next match and you've got an electrical problem on your robot, you will really appreciate the time you took to wire it neatly so you can see where your wires are going. Same thing with labeling of your cables. We use a specific labeling system on our robot so we can identify where both ends of the cable go. Again, we found that really useful in the heat of competition. You don't have time to be trying to remember where that wire went. As I said before, keep power and signal cables as short as possible. The connectors on the Robo Rio that Graham pointed out to you earlier, we've had problems with them coming undone. It was suggested to us, and we found it very useful, to use very small amounts of hot glue to hold those connectors in place on the Rio is one solution. There are some other solutions. You will find if you do a search, many other teams have produced 3D printed covers or brackets to clamp those connectors in place. They're another alternative for you. There are also specially designed circuit boards that can be used to connect to the Rio and then interface to more reliable types of connections. So certainly consider the hot glue, but be very careful with the amount of hot glue that you put onto your Rio. Protect the open ports on the Rio. So Graham talked before about the covers. He also talked about taping over the ports. So any ports you're not using on the Rio, tape them over so bits of metal can't get in there and cause short circuits. And we would suggest, based on experience we've had before, to use what's called shielded cable for your sensor connections like encoders and not just normal unshielded cable. So in the little picture on the slide there, you'll see basically shielded cable has a metal braid shield around the outside of the cable, which can be used to reduce the level of electrical interference which is induced into those sensor cables.
So as Simon mentioned before, one of the critical parts of the robot is the CAN bus, and if it breaks, it doesn't work. So one of the things that we've found is useful is running a test on the CAN bus. So one particular thing about CAN bus is it has a 120 ohm terminator on each end. All the nodes in the middle of the CAN bus, the terminator should be switched off, but the node at each end, the terminator should be on. And I believe the Robo Rio terminator is permanently on, and the PDP terminator comes by default on. So what tests that can be done on the CAN bus is basically you go to one end, so the Robo Rio, disconnect it and look for 120 ohms. That will basically measure that the whole CAN bus is complete with a terminator on the other end. Then reconnect that, go to the other end of your CAN bus and perform the same check, and you'll know that your CAN bus is complete and correctly set up.
So other things can come down to the position of the radio. The radio is a Wi-Fi device like any other device. It needs to be able to get the signals that are being sent out from the field. So mount it high on your robot if possible, and mount it in a safe position where it's not going to be wiped out on field elements or other robots. As we said before, use both power connectors on the radio. So use both the barrel connector and the PoE injector. Also, again, use hot glue, small amounts of hot glue to hold those connectors in place so they don't come out. Hot glue is good because if you use small amounts of it, you can remove it. If you use too much, it gets harder. As I said before, avoid putting too much pressure on the top or bottom of the radio so that you don't run into that risk of shorting the power supply in and out, and also consider using some kind of rubber mount or something like that to reduce the amount of shock that's transferred from your robot frame through to your radio.
Useful resources. So there are a lot of documentation resources out there. Ones we would suggest are the WP-lib documentation that's available on the internet, talking to other teams, the help desk, and the how to wire an FRC robot. So in the 2020 game manual, page 86, there is a link in there directly to a WPI lib documentation on how to wire the robot. As far as other teams go, well, if you fail inspection at a match, I'm sure there'll be plenty of teams who are willing to help you out and get you going again, but that's probably the timing something you'd like to avoid. If you go to the Project Bucephalus webpage, there is a contact us. You can contact us on our Facebook. We'd be more than happy to help you with this sort of thing. But there are also plenty of other teams that would be happy to help you as well. So you're never alone in FRC. There's always plenty of people to ask. And yeah, give us a call if you need anything. Now we're up to our first question time. So does anyone have any questions?
Actually, can I just point out to, it may have been confusing before, the radio must be powered from the VRM. Yes.
The radio is powered from the VRM.
Yes.
The Robo Rio is powered from the PDP.
That's right, yes. So that's what I was trying to say before. The radio is powered by the VRM. So just in case we confuse that, radio connects to VRM.
So it doesn't look like we have any questions so far. You guys are explaining things so well, so keep on going. If more questions roll in, we'll let you know.
All right, everyone wake up.
Stand up, stretch.
So this one's yours.
Mine, is it? Okay, so we want to move on to talking about sensors. Sensors are all those different kinds of devices that can provide information or feedback back into your Rio to allow your robot to operate depending on what's going on around it. Places where sensors can be really useful is in your autonomous period. Things like when you're extending arms or intakes, sensors allow you to know where that intake or where that arm is. Even knowing where you are on the field, so you can use sensors to help you understand whereabouts your robot is on the field. For lining up with objects, sometimes you will notice the field has tape markings on the floor, which can be used to line your robot up for different things. Also, depending on where you are in the development of your robot, you can even use sensors to help you line up the targets. So for example, if you want to shoot through the high goal, you may be able to use sensors to help you do that.
Then you also have position detection sensors, which are on-off type sensors. They will tell you if a part is in a specific position. So you've got limit switches and Hall effect sensors. So you can have a limit switch at the end of travel. The motion will hit the limit switch, or you can have a Hall effect sensor off the side with a magnet on it, and it'll pick up when the part is lined up. One issue with those, though, is if you can travel past them, they turn off again. So just make sure you account for that in your design and your coding.
The other kind of sensors that we can look at are sensors that can detect movement and travel of parts. So they would be things like encoders, which we've talked about before, or mentioned before. Encoders provide a count, usually of the number of rotations or a certain number of counts per rotation of something, a motor, a drive shaft, a colour wheel spinner, all sorts of things. So an encoder allows you to see how far and how fast something has moved. There are also what we might call things like accelerometers that you might want to use, or even gyroscopes later on. These are more sophisticated devices that can help you understand how far your robot has actually travelled, how fast it's travelling, which direction it's facing, how it's turning, all sorts of things like that, that you may use down that journey of developing your robot. You may start to use some of those more complicated or sophisticated sensors on your robot as well.
Further sensors that are available are ones for measuring distances, so ultrasonic or laser. So they can be used for following a wall or knowing how far you need to shoot. And there are a variety of ways of connecting those as well. Some of them have digital interfaces to I2C or RS232, and you can also connect them, and the simpler way to connect them if you're just starting out is just with a simple analog to the analog input of the RoboRio.
There are some other sensors like colour sensors. So a common example that if you've built a robot for the 2020 season was the spinning wheel or the control panel. I shouldn't call it the spinning wheel, it's the control panel. The control panel, the kit of parts contained a colour sensor which could be used to enable you to determine where the wheel was at any particular time. They can also be used to look for lines on the field. As I mentioned before, you can have coloured lines on the field which can help you know where you are. You can have light sensors. An example again in 2020 where you may have wanted to use a light sensor was for counting balls in and out of intakes. So you knew how many balls were in your intake or your shooter at the time. The other one, again, which Graham pointed out briefly before, is things like vision systems. So moving into where you've probably all heard people talk about line lights. If you've been to an FRC competition, you will certainly have seen a line light. You can't deny the bright green light that comes out of them. So they're a sensor, but they provide information about what the camera is actually looking at.
So types of connection. When we had a look at the RoboRio before, the ports on it, there were the digital I/O ports, and they are useful for things like encoders, Hall effect sensors, or limit switches. The Hall effect and limit switches are a single wire into a digital input-output that's either on or off, whereas your encoder, you have two pulse trains. So you have two different digital inputs, and they each receive pulses, and the way the pulses count, which one comes first before the other one, will let the RoboRio know which direction you're going. So you can count forwards and reverse with the double pulse train for those. The next type is the analog input. So they can be used for, we talked about ultrasonics and light sensors and things like that before. They can give you a voltage. You can also just use a potentiometer, a variable resistor that changes resistance on rotation to wire into an analog. And your RoboRio will convert that 0 to 5 volts analog input into a digital value within your program. Analogs can be a bit more susceptible to noise, so definitely screen the cables, but then again, so can your fast pulsing encoders. Other connections are CAN, so there are devices that will connect and sense things by CAN, but also your motor controllers. The CAN motor controllers will generally have the ability to connect an encoder, or if you're using a brushless motor, they come built in with encoders. So you can read your wheel positions and that sort of thing directly through the CAN bus. SPI can connect to sensors, and probably the most common digital one is the I2C. So in the, I think we said before, the 2020 kit of parts included a color sensor for the, not the spinny thing, the control panel. That's the one.
That's the control panel.
It included a sensor for that, and that's wide in I2C. There are other I2C sensors around, and you can even build your own. One thing we've missed there is RS232. There is a kit of parts ultrasonic sensor that does support RS232 if you want to do the code for it, which isn't exactly straightforward, but it is possible.
So what have we learned over using sensors over the years? Well, number one thing we've learned is that sensors fail. So despite your best intentions, sensors will fail. That may be because of cable issues. As Graham will talk a bit later on, we've had issues with cables with sensors. Sensors can fail. You can have mechanical failure. We've had cases where we've had encoders that have stopped receiving data because the mechanical connection between the encoder and the shaft failed. So you need to allow for, when you're using sensors, to consider the possibility of what happens when a sensor fails. And I'll probably let Graham move on and talk a little bit more now about what happens when sensors fail.
Yeah, sure. So, what did you want to talk about?
Oh, so one classic example, in our 2019 robot, we had a Bobcat arm, which would raise up to move our hatch panel deploying device to where it had to be deployed at. The rocket, that thing.
Yes.
We had an encoder on that arm, which was designed to allow us to work at, because it needed to work at 3 different levels, depending on the height of the rocket ship that we were trying to place a hatch panel on. When our robot first enabled, it would attempt to move the bobcat arm to the lower position in preparation for picking up things from the loading station or placing hatch panels. Our encoder failed. So our software said, move the arm until the encoder says you're in the lowest position. But our Rio never saw that the encoder got to the lowest position. So we suddenly had a situation where the bobcat arm would shoot at full speed, as high as it could possibly go. It nearly took my head off once when we enabled the robot in the pits and I had my head a bit too close to where the bobcat arm was.
Yeah. So if we just jump to the photo on the next page, please. This was the result of, actually, this wasn't a sensor failure. This was a control signal failure. Our robot that year had these two arms that came out forwards to lift it up, lift the front of the robot up, and had these elevators that came out the back to lift the back up. On the arms on the front, there were two wheels with motors, which at that particular time were the only wheels touching the ground because all the other ones had been lifted into the air. We lifted up and could not drive onto that HAB platform. It turns out that the PWM cables into the Robo Rio had come out. Either they'd been jolted out during competition or pulled out inadvertently while working on the robot. And that's one of the reasons why Simon was talking about the hot glue to hold things in. Once that happened, we got stuck there. 6510 Pymble Ladies College, they were generous enough to give us a little nudge to get us up on the HAB platform. Unfortunately, it was right before the buzzer and we couldn't quite get far enough on and slowly tilted and fell on top of them. I did hear a rumour later that we'd severed their camera cable, so sorry about that, Pymble. But that's the result of cables coming off. The next slide. This was in the quarterfinals for the Southern Cross Regional. We'd picked a good alliance and got on the field, good feeling about it. And yeah, our elevators, this time on the back of the robot that lifted up for the HAB climb, the encoder came off. It physically came off the shaft. While it was coming off, it spun just a little bit. And because the control system within the robot, the Robo Rio, it was configured to position control, but it was always position controlling, even when we weren't actually using the elevators. So it saw the elevators weren't quite in the right positions, so they started extending during the match. Now, of course, that starts to become a bumper violation. If we go to the next slide, once it gets a little bit worse, we're kind of stranded. So that was a very sad quarterfinal for us. We did lose that particular match. But again, that's the result of an issue with a sensor. All right, next slide, please. And we're up to questions. So we're really, really well organised. We're 8:23, we're spot on time. So we've got some time for some questions.
That was excellent. So we have a couple of questions that have come in. The first one has to do with batteries and what to do if there happens to be a battery spill, both on the field or in the pits, as well as what should you have in the battery spill kit?
So the battery spill kit is actually defined by the FRC. There's an FRC safety manual which will tell you exactly what to have in it. And we do have one. Lyndall's just running out to get it now. But basically, the main part of it is the bicarbonate of soda to neutralise the acid. I believe there's a couple of other things in there like gloves to stop getting the acid on you.
Here's one we prepared earlier.
Thanks, Lyndall. Yes, so we have really thick rubber gloves and we've got a couple of containers of bicarbonate of soda. And of course, a tub that doesn't have any holes in it. To contain, you put the battery in the tub so that it's contained. And cleaning stuff, Chuck's wipes. Yes, but yeah, that is specified in the first safety manual.
Excellent. Another question that has come in is you had talked a little bit about electrical interference in the cables and using shielded cables. The question is, do you have any advice on how you would track down electrical interference on your sensors?
Well, I think the first thing is to start with best practice. So you look for, well, when you do shield your cable, screen your cable, you only screen it at one end. Screen it as solidly as possible to your 0 volt line. But yeah, as far as looking for it, it's when you get erroneous operation of a particular sensor, and it can also happen when you're running a particular motor. So I would start with powering everything else off and moving the particular mechanism by hand, watching the numbers on your shuffleboard or whatever using your driver station, just to make sure that they're nice and smooth and they're not jittering about or taking off in one direction. And then either reroute your cables as far as a best practice type change to how you're doing things, or start turning other systems on and see if you can find out what's interfering with it. But the thing I would most say about that is try and do that as early as possible. You want the confidence of having run your robot for a while after you've solved the problems, so it's not always in your mind that, oh, that could be a problem. You want to know you fixed it before the game.
There is a rumour that a certain FRC team may have wrapped aluminium foil that they got from the catering department at a competition around their encoder cables in a desperate attempt to stop that interference. And it worked.
Yes, our robot didn't have that interference after we did that.
Aluminium foil insulation tape.
So a follow-up question to that is, are any type of sensors more susceptible to that sort of interference?
Yeah, so your basic on-off type sensors are not very susceptible to that. They're just on or off. It's the ones where you're detecting either lots of moving edges, such as your encoders, or you're looking at a very fine change in a voltage level, such as your analogs. They're the ones that are most susceptible to that sort of interference. Okay.
The next question is, do you ground shielded cable to the robot frame or to battery ground?
Okay, so we talked about it before. The rules say that you can't have anything connected to the frame. We had an issue at DDU last year where one of our encoder mounting kits had failed, and it was actually causing the encoder to ground to the robot frame. We got stopped at a robot inspection and we had to repair that fault. So the best practice to be sure that you don't have problems with inspection is to ground the shield to the 0 volt on your electrical system, not to the robot frame. Then you can't have that problem.
We've been told different things by different robot inspectors, but yeah, as Simon says, the safe way to do it is to 0 volts. That no one will have an issue with you if you do that. And electrical engineers will debate this till the cows come home, way outside of FRC level. For an FRC robot, stick it on the 0 volt line. It's good enough for an FRC robot, and it's the only way to guarantee to be legal. But only do it at one end. Do not ground it at two ends. Just ground it at your Robo Rio end. Leave the other end insulated.
Well, it looks like those are all of the questions that have come in. So I wanted to say thank you. This was excellent. I know that a lot of people learned a lot of things. Simon and Graham, both from Project Bucephalus, you guys have done a remarkably great job. Thank you so much. And if there are no other questions, I think we will call it a night. Any closing comments from you guys?
No, thank you for putting this on, Laura, and organising it for us. And thanks everyone for watching, and have lots of fun with your robots. That's the important thing.
Yes.
Awesome. And if they have
electronics is fun.
If they have additional questions, can they get in touch with you?
We'd love you to, yes.
Absolutely. So as we said before, Project Bucephalus website has a contact us option. The Facebook page, we're available through that. Luann knows how to get in touch with us, so do a lot of other teams. We're always willing to help. And we've got, not just Simon and I, we've got a lot of kids here who have done all sorts of weird and wonderful things with robots who'd love to share it with you.
Awesome. Well, have a great night, everybody, and we'll see you all next week.
Thank you.